Hello viewers, we are looking at Laplace transform. Laplace transform, always denoted as capital L, is the techniques that we use to transform from time domain to frequency domain. So it is, if you have an expression that is f of t, it means that you are changing from this to this. So when you do this, that is Laplace transformation. And this, it is used, you can use that to with the help of this formula. You can always use this expression to convert an expression from time domain to frequency domain, and where s is a complex function. So we can use this technique to convert numbers, exponentials, trigonometries, and all that. So let's start with one, integers, where we can present as a. So Laplace transform of a, and this a can be 2, 3, 4, is actually equals to, from 0 to infinity, a is here. We have st dt. So when we actually integrate this expression, we are actually having a. Of this we have minus into exponential this divided by s. So we have infinity and 0. So having done this, we conclude that the Laplace transform of this becomes minus s infinity. We have s 0 divided by s, because you know a is there. So we have that this is giving us 0 divided by s multiplied by a. So we have a divided by s. So Laplace transform of a is actually a divided by s. We can have Laplace transform of 2. This will be 2 divided by s. Laplace transform of minus 3. We have minus 3 divided by s. So that is a technique that is can use to transform and just an ordinary number. So the next one we look at is exponential expression. Exponential function. Exponential function. We can use 80. So having done this, we can introduce Laplace transform of 80 is going to give us exponential. It's going to give us integral. We include this st dt. So by further rearranging this 80, we are having exponential this into minus s minus t a all t. So finally we can actually differentiate this expression, and this is going to be exponential this t divided by minus this, and we want to do it with. So looking at the expression here, we have that infinity to this will be 0 and this is 1. So Laplace transform of this will give us minus this. And also we should also note that the Laplace transform of minus a is giving us this minus a, and that will be 1 divided by this plus this. So where a is the normal numbers, so we can have a Laplace transform of 2 t exponential 2t. This will give us this minus 2, and also Laplace transform of minus 2t will also give us this plus this. So this is the techniques on how we can transform an exponential expression. So the next on the list is trigonometric functions. That is the next we are going to do. This will take place. We can have the sine 80 and also cos 80. We can actually, this is the three case, we can actually carry out the Laplace transform of trigonometric functions, that is sine 80 or cos 80. And we first of all introduce that cos 80 is the same thing as exponential this plus this divided by 2, and also sine 80 is the same thing as exponential this 80 minus this divided by 2j. So having known this, we can actually look for the Laplace transform of cos 80 and also of sine 80. So for Laplace of sine 80, we can have this. This is giving us sine 80, and the same thing as Laplace transform of this minus divide this by 2j. So using the main formula for Laplace transform, we can use this, that sine 80 is going to be integral 0 to infinity, include this. So this is jt minus jt. So you multiply this with st dt. So, and the next is for us to simplify the expression to see the outcome of it. So in this case, we can rearrange the expression as this is going to give us from 0 to infinity. So this can come in here, and we have exponential jt dot exponential minus st, and this will be minus exponential minus 80 dot exponential divide this by 2j and dt. So you can also further express this by stating that this becomes exponential this and this. You can combine it. We have minus s plus ij minus this, that is s plus ij. This is t and this is t. Divide this by 2j. So the next is to carry out the actual integration of this expression. So we have that to integrate this. So first of all, let's keep this and integrate this. So we're going to have minus exponential s and ja. This is minus the same thing here. We have s at divided by let's look at this again. So when you look at this, you realize that this is going to give you minus from here. So we have this, and when we have this, so this is going to give us minus it. But whereas this will maintain this minus this, we can include this. The boundary condition becomes that. So when we introduce the boundary condition, we are going to have 2j into 2j into, for when we integrate this, this will affect this minus and this will be plus. So this coming here, we're having 0, and this coming here, we're having 1. So we have that 0 minus, that is for infinity. Introduce this to this, we have into minus 1 j list, and also to this one we have 1 this aj. So at this point we can actually rearrange the equation. That Laplace of at becomes 2j into this minus this. So carry out the LCM, and this time this will actually give us this squared plus this, and this will give us s, and this will give us minus s plus js. So when we finally look at the expression, we have that Laplace transform of sine at is giving us, this will cancel out. Please recall 2j. So this will be 2j into this divided by plus a squared. So finally, Laplace transform of this is t will give us this is 2 j2a will give us this cancel out. We have a divided by this plus this. So at this point we can also say that Laplace transform of sine 2t is 2 divided by this plus 4. Laplace transform of 3t is giving us 3 divided by this plus 9. So that is how we go about it. on the analysis. Let's also look at Laplace transform of cos theta or cos 80. So for cos 80, we have that cos 80 is the same thing as exponential this and plus minus 80 divided by 2. So when we include this in the formula, we are having that Laplace of cos 80 will give us this. So include this j80 plus minus j80 divided by this. So multiply this with this and that. So rearranging the expression, we have cos this 1 over 2 exponential between this and this. So this is giving us j80 and minus 80 plus minus j80 minus 80 divided by okay, 2 is here already. So this is by dt. So we can actually express this by this analysis. We have that Laplace of cos 80 is giving us exponential this. So we can include this. We are having this s I a plus this. This is going to give us negative. This is plus divided by 2, and we are having dt. So actually we come to realize that the Laplace is actually 1 over 2 divided by exponential this. This include 2 divided by minus is 2. So this is plus. The same thing will change to negative. So we are having exponential this divided by s plus this. So we will include the boundary. So this will give us that Laplace of cos 80 is actually equals to we have 0 into this. So this is going to be minus 1 divided by this. We also have this and this. So this is giving us, this will cancel out. We have this plus s plus aj. So taking the LCM, we have this plus this. So this will give us that s plus aj plus this minus aj. So this is into 2s divided by this plus a squared. So the Laplace transform of cos 80 is equals to s divided by a squared plus this. So that is the Laplace transform of cos. It's a Laplace transform of cos 80, and we can acknowledge that cos 2t is s divided by this and plus 2, and also cos 3t is something as s divided by this plus this. So I want to believe that the analysis of the transformation was fruitful, and please try and watch my next video on Laplace transform. Thank you very much.